right. If you are not in the pair deck, I put the link here in the chat. It looks like we got 14 people in. Out of our 14, we got 5 protons, so we're sitting at an atom of boron. The most common isotope of boron with 6 neutrons, although that just jumped up to 7, and 1 little old electron. Hopefully, if you are my little electron friend, you can let me know if there's anything I can do to help, okay? But we're going to officially get started today with covalent compounds. By the end of class today, through what we learn in class and then what you're going to learn in your ed puzzle, you are going to be able to name binary covalent compounds, meaning covalent compounds with 2 elements. And you're going to see that it's close to how we name ionic compounds, but with 1 extra step to it, okay? And in class, I'm going to show you why we need that extra step, because it literally could be life or death, okay? We'll do that here in a moment, but we're going to start off with a review. The last review question we didn't get to in class yesterday, which is another crisscross. We have 2 compounds, calcium oxide and strontium phosphide, but this time you will run out of numbers if you don't check to simplify. So spoiler alert, at least one of these will need to be simplified, so make sure you double check that there at the end, okay? I'll give you guys about 2 minutes to work on this, okay? Alrighty, so far, pretty much these look all right. If I show your responses, we can see kind of overall a general consensus. I see mostly reds over here on the calciums. I see mostly blues and greens, so those look good. I am going to walk through this one step at a time just so you can see it one more time, because we're not going to be doing a lot more of this practice because we only do this crisscross with covalent ionic compounds. Covalent's going to be different. So calcium, group 2, atomic number 20, starts off with 2 valence electrons that it wants to say goodbye to. So calcium's going to take on a +2 charge. What charge is oxygen going to take on when it forms ionic bonds? You can type your answer in the chat or speak.
-2.
Beautiful, -2. And so calcium has the -2 charge. I'm sorry, +2 charge. Oxygen has a -2 charge. Some of you might see this and just jump to the answer, and that's great. That's going to be helpful later on. Some of you may need to go through the whole process, which is totally fine. I'm going to crisscross the 2 from the calcium down to the oxygen, crisscross the 2 from the oxygen down to the calcium to give me 2 calciums for every 2 oxygens. But that ratio is not finished, and you need to finish it because strontium, spoiler alert, also in group 2, right underneath calcium, needs a +2 charge. But I don't have any more number 2s. And that's because if I have 2 and 2, those can actually simplify to 1 and 1. Okay, and then as Lewis asked earlier, do we need to include the 1s? No, you have permission to be a lazy chemist. You can get rid of them and just write CaO. I'm going to leave the 1s in there just to emphasize that this question has been answered. But otherwise, that's it, okay? Some of you may have figured out the shortcut where if I have +2 and -2, same number but opposite charges, like positive and negative, they're going to cancel each other out, and you can leave it just with 1 to 1. Okay? Strontium has a +2 charge. Phosphorus, most of you figured out, has a -3 charge. Crisscross and 3 and 2 is already simplified, and so you can leave this as SR3P2. Okay? So a few reminders with this before we jump into covalent compounds. This process of crisscrossing and simplifying is only done for ionic compounds. And that's because ionic compounds, they don't exist as little units like we're going to see covalents do. They actually exist in repeating crystal patterns, as you learned right before break with that online tutorial. And so when you're saying the chemical formula, you actually just say the smallest ratio in which these elements can work together evenly. We're going to see with covalents, you don't want to simplify the ratio because that will change the compound entirely. Okay? So speaking of covalent compounds, here is our review from we went over yesterday. We have ionic, covalent, and metallic. We're done with ionics, we're done with metallics, and we're going to spend the rest of the unit focusing on covalents. And covalent compounds are going to occur only between nonmetals and are going to be sharing electrons. Okay? And I'm emphasizing this because moving forward, anytime you're asked a question such as name a compound, draw a compound, write the chemical formula for a compound, what type of reaction is going to happen with this compound, you need to know what type of bond it is. You need to know if it's ionic, covalent, or metallic by looking at your element types, okay? So read carefully because all of my classes today, somebody's made the same mistake, but your check-in question, drag the check marks to the chemical compounds that are being held together by covalent bonding, okay? Yesterday we did ionic, today is covalent. You'll notice you have 4 check marks, which means you don't know how many of these are correct. All of them could be covalent, one of them could be covalent, 2, 3, 4, 5 could be covalent, not 5, there's not 5 of them. But you get the point. Okay, you can leave your extra check marks off to the side, but for any that you think are covalent, drag one of those check marks and plop it right next to it here. Okay, don't hesitate to consult your best friend called the periodic table of elements, my friends, so that you have it. Okay. Also, just a general noticing, we have 18 people in the pair deck and 24 in the Zoom call. So that's about a third of us not participating. Maybe not getting a participation grade for today, if today's the day. Because once a week, you get a grade for participation. A random day every week. All right. Happy to see this. Yep, good job, Justin, helping out your classmates. On the periodic table, reminder for metals versus nonmetals. Above the staircase are your nonmetals. Below the staircase are your metals. The way that you can remember that is one that you should know for certain is not a metal is oxygen. So you can look where oxygen is and remember that all the ones around it are also nonmetals. And you can also remember that iron or copper, silver, and gold are metals. And so you can use that to help you remember that under the staircase is the metals. Directly on are your metalloids, except as Justin reminded us, aluminum is officially a metal despite its location. Similarly, hydrogen, even though it's technically on the left side of the periodic table, it is a non-metal. Okay, and so if we look at your classmates' responses, you will see the vast majority of check marks are here on NF3 and CO2. And so if we double check those, we have nitrogen up here above the staircase, nonmetal, fluorine above the staircase, nonmetal, and 2 or more nonmetals make a covalent bond. Similarly, carbon and oxygen, both nonmetals, so those guys are going to be covalent as well. But let's double check these other 2, lithium oxide and calcium fluoride, just to be sure. Lithium, way over here in group 1, is a metal, and metals do not ever form covalent compounds. Metals will always either form ionic or metallic bonds, and similarly, calcium is located here in the metals section as well. What we're going to do now is we're going to practice naming compounds, but we're going to do so as if there's only one way to name compounds, okay? I've taught you how to name ionic compounds where you take the metal name first and then take the non-metal name and change the ending to IDE. I want you to assume that that is how you name all compounds, okay? Spoiler alert, it's not. And so on the next screen, there are going to be 2 chemical compounds, and I want you to name both of them. You're going to type their names in the pair deck, okay? You can write number 1, the name is blank, number 2, the name is blank, or just organize it in a way where I can see both names, okay? I'm going to give you about 1 minute to try this. Your 2 chemical compounds are H2O2 and H2O. Please try and name these chemical compounds. I just realized I could have done this a different way. Maybe next year. We'll try these. Also, no common names. Yes, the second one is water, but we're using fancy chemistry names up in here. Okay, I just want you to pretend you're naming them exactly the same way you would have named them as we've learned previously. Okay. All right, very good. If we look at your classmates' answers, some of us spoiled the fun a little bit, but most of you guys did exactly what I asked. And what I asked was for you guys to name these compounds by naming them as we've named compounds so far, which was to take the first element and then change the ending to IDE. So if you look at this screen share, you will see that for the first compound, we have hydrogen oxide, which matches because we have hydrogen first, oxygen second, change the ending to IDE. And for the second compound, interesting, we also have hydrogen oxide. And that is true because hydrogen bonded to oxygen will change the ending to IDE here. Okay, and so if we were to follow standard naming rules, both of these compounds would be called hydrogen oxide. And that's why Omar was asking, does he need to only put one name? You can only put one name because in theory, these would have the same chemical name. But my question for you is, are these the same thing? Can they both be called the same thing? One of these is what? Which one of these does everybody know? You go out in the street, everybody knows it. They know it's water. Okay, I'm getting this in the chat. Water, H2O, is water. 2 hydrogens, 1 oxygen. But if I add another oxygen, H2O2, is that still water?
No.
Does anybody know what it is?
Hydrogen peroxide.
Hydrogen peroxide. Hydrogen peroxide, my friends, is not the same thing as water. Water is something that you need to live. Your body is 75%-ish water. The earth is 75%-ish water. And we need to drink about 1.5 liters of water every day to stay hydrated. That's why if some of you guys got in here early, we were talking about colors with yellow and not yellow. And yeah, if you're dehydrated, your urine will tell you because it will be darker yellow. If you are hydrated, your urine, your pee will be more on the clear, pale yellow side. Okay? But if we ran out of water, do you think we could go around and just drink hydrogen peroxide in the same way we drink water?
Yes.
Would it work out in the same way, Karma?
Obviously.
Obviously
No, not.
I'll finish your sentence for you. Hydrogen peroxide, my friends. Hydrogen peroxide, by the way, if you don't know, is the stuff you buy at the pharmacy, the drugstore with in these brown bottles. Okay, and hydrogen peroxide is used when you cut your hand. You put hydrogen peroxide on the open wound, and what does it do, my friends, when peroxide touches your hand?
It burns.
It burns, it fizzes, it bubbles, and that's because it's eating away at the bacteria. Very good job, Lewis. And if I put water on my hand, that's not going to happen. And that's because these are completely different chemical compounds. Okay, we are going to see that if we change even one number of the element, it's going to be a completely different chemical compound. Okay, this is just one example. By the way, the peroxide that you buy on Earth, Hugo, you're messing me up reading your comment. Yes, your Earth, fine. The hydrogen peroxide you buy at the drugstore is actually only about 3% hydrogen peroxide. The rest is water. But that 3% has that much of a reaction. If you've ever had your hair bleached with peroxide, that's about 6% peroxide. And so if you actually drank 100% peroxide, your whole esophagus would it would be gone. It would say goodbye and be eaten away by this compound. And so because of this, the reason I'm pointing this out is because these two compounds cannot have the same name. Because if you go to the doctor and they're like, oh, just drink some hydrogen oxide, they're going to be like, which one? Because it's very different, okay? Karma's stomach in your acid is hydrochloric acid, HCl. We'll talk about that a lot in our next couple units, okay? And so they need different names. Most people are going to call these water and hydrogen peroxide, which is totally fine. But if you notice down here at the bottom, I have put names on here that are going to more so follow the standard naming rules for covalent compounds. Okay, water's official name, I scared you to death with it at the beginning of this unit, dihydrogen monoxide. Remember that? I gave you all like panic attacks, but it was just water. Hydrogen peroxide is actually more so called hydrogen peroxide, but if you wanted to get fancy, you could say dihydrogen dioxide. Okay, and so there are different things that you need to add to the name to make sure your reader knows exactly which form of that chemical compound you're talking about. Because unlike ionic compounds, the ratio of elements can be different. Naomi, yes, that's correct. Spoiler alert. Okay, and so hydrogen and oxygen can bond to each other in different ratios. hydrogen and carbon can bond to themselves in like an infinite number of ratios. So you need specific names to tell us specifically what ratio you are talking about. Okay, before I show you one more life or death situation, here's ChemCat for the day. H2O is for water, and H2O is hydrogen peroxide. What is H2O for? It's for drinking, you ding-a-ling. You drink water. You get it? Haha, so funny. You get it? Anybody get it? Josh got it. He just did that. He loved it. It was great. Okay?
Okay.
There you go. Justin's second gold star of the day. Did I have a better execution in this class? But yeah, the chemical compound H2O4, which would be dihydrogen tetraoxide, does not exist. But what is H2O used for? For drinking and watering plants and all that other good stuff. Okay. Last example for the day before I set you off on your merry ways, we have CO versus CO2. If we named these the same way we named ionic compounds, these would both be called carbon oxide. But these are not the same thing. Okay, you can either type your answer in the pear deck or you can just let us know. Does anybody know what either one of these are officially named and you're more used to naming them that way?
Carbon oxide.
Carbon oxide is not enough information.
Carbon monoxide.
Carbon dioxide.
Carbon monoxide, and I see Jarrell is typing carbon dioxide. Okay.
I said that.
I didn't hear that. I'm sorry. Okay.
You said it over me.
Which one of these is carbon dioxide? The first one or the second one?
Second one.
The second one. Why do you think it's called carbon dioxide?
Because of what
There's two.
Naomi said before.
There's two oxygens. Very good. The first one is called carbon monoxide, which some of you may not be as familiar with, but carbon monoxide is very different than carbon dioxide. Okay, carbon dioxide, everybody can just go, and you breathe it out, cellular respiration, all that good stuff. It is in the air around us. There is too much of it in the air around us, causing like climate change and global warming. But in and of itself, it can't kill anybody. But carbon monoxide, my friends, is in fact a gas that can kill you. Okay, in your apartments, in your apartment buildings, in your houses, you all should have by law a carbon monoxide detector, and it's not measuring how much carbon dioxide you breathe out, but it's measuring how much carbon monoxide is in the air. Because if there is too much carbon monoxide in the air, you could have headaches, nausea, dizziness, breathlessness, collapsing, loss of consciousness, and they're being nice here, you could literally die if you inhale too much carbon monoxide. Okay, and so carbon monoxide is going to be very different than carbon dioxide in that it can kill you, and so that is why these compounds have different chemical names. Okay, Naomi asking a question, is the prefix mon or mono? It is mono, but just to make it sound nicer, they don't say monoxide. They just make it sound nice and fluid and say monoxide. Okay, Carmine, I mean, we can also die from CO2 as well, though. Yes, but that is more so due to lack of oxygen rather than the carbon dioxide actually doing anything bad to your body. Carbon monoxide actually does bad things to your body. Okay, it affects your brain function and all that good stuff. Okay, di means death, but di means two. Okay, and so these are going to be the covalent prefixes that you are going to be using when naming covalent compounds. And so what you're going to be doing today for your asynchronous task is I have a short Edpuzzle video that did post in this class, very good. And it's this guy, he's a very good YouTuber about chemistry. If you ever are stuck, you can go to this guy's YouTube channel, it's pretty good. But it's going to walk you through how, when, and if you use these prefixes when naming covalent compounds. Okay, and so it's all multiple choice. If you mess up, I can actually reset your progress on Edpuzzle now. It's like a new feature I just saw. So if you mess up, just let me know. I'll reset it for you, and you can do it again for a better grade. Okay, you better believe these questions will be in your warm-up tomorrow, so please make sure you get this Edpuzzle done before class starts tomorrow so that you're ready to go. And I may also throw in an ionic compound just to see if you're paying very close attention. Okay? That is all I have for you today, my friends. If you would not mind either giving me a thumbs up or a thumbs down on today's pear deck, you can go ahead and take off and go enjoy the rest of your day. Make sure you get your ed puzzle done before class starts tomorrow, and I will see you then. Okay? Goodbye.
Goodbye, miss.